Hi guys, hope you are doing well. Welcome back to my channel. Today I'm going to teach you displacement reactions and hopefully I will demonstrate a small experiment about the displacement reaction. Look at that. This is a common topic between the GCSE and A level. Displacement reaction. We have so many types of chemical reaction. Neutralization reaction, acid-base reaction, redox reaction, displacement reaction. Displacement reaction is a type of redox reaction. So some reactive metal, we have some reactive metal. Suppose we have A, B, C, D, and we have suppose E, F, G. So suppose these are the reactive metal which displace, which kicks away or occupy the position of E in the chemical reaction. So these are the less reactive metal, less reactive. So a very reactive metal displace a less reactive metal from its chemical reaction. For example, look at that. Zinc can displace copper. Yes, zinc displace copper from zinc sulfate solution. Zinc is a metal, very active metal. It displaces copper from the copper sulfate solution and form zinc sulfate plus copper, which is get deposited. This is a solution. This is in the solid form, and this is in the aqueous form. Is a light blue color solution. I will show you soon. And we have nickel, which is also a reactive metal, solid, displace copper from its aqueous solution and form nickel sulfate and NiSO4 plus copper get deposited. Okay. Fe, which is iron, Fe, solid form, displaces copper from its aqueous solution. We will do this experiment soon, guys. And it form FeSO4 plus copper get deposited. All they are in zero oxidation state. Okay, I'm going to soon start a redox reaction. Oxidation is the loss of electron, reduction is the gain of electron. So displacement reaction, which is a type of redox reaction. Look, in all the cases, zinc displaces copper. Can we write the half equation? Yes, we can write the half equation. This is blue in color and this is pale green. Okay, look at that. Zinc is in zero oxidation state, give away the electron and become Zn 2 plus 2 electron. All the ions you have to write aqueous, solid form to as solid form to become aqueous form. Okay, Cu2 plus, which is in 2 plus form, gain 2 electron from zinc and become copper, which is get deposited. So I will show you this experiment and let's see what will happen when we dip a nail in copper sulfate solution. So this is a loss of electron, this is gain of electron. So zinc get oxidized and copper get reduced. So displacement reaction is a type of redox reaction, is a chemical reaction. Okay, can nickel displace copper? Yes, it will displace copper. Okay guys, you want to copy down that one? Okay, you know that we have to take care and take a precaution when we touch any chemical. That's very important, guys. So always use your PPE, like you have to wear your goggles, wear your gloves and a fully buttoned lab coat. Yeah, now look at that. This is a copper sulfate solution. That's my copper sulfate solution. I have added roughly 75 ml of water in 4 5 grams of copper sulfate. You don't need to be very accurate, that's fine. And I want to show you, look at that, this is the iron nail, and we can dip in that copper sulfate solution. That iron nail displaces iron, look at the Fe, displaces copper and form ferrous sulfate solution, which is green in color, and the copper get deposited on iron nail. Do you think the copper get deposited on the iron nail? Let's see. We have to wait for few minutes because these reactions are not quick reaction, not vigorous reaction. I have to wait for 5 minutes, or you can boil the solution. Yeah, what happened? What happened? Can you guess what will happen to that nail? Yeah, that nail, on the surface of the nail, copper get deposited, and this blue color solution magically turns to pale green. That's a beautiful reaction, guys. Okay, I want to wait for a few minutes so that the reaction take place. This is the overall reaction. Look at that one. Fe, which is the iron nail, displaces copper from the copper sulfate solution. The original color of the copper sulfate solution is blue, like aquamarine, and at the end the solution become pale green, and the copper get deposited on the surface of the nail. Okay, this is a displacement reaction. Fe takes the position of copper here. Okay, then look at that one. I kept nail for roughly 10 minutes. Look at the color of the solution. You can clearly see the difference in the color of the solution. This is pale blue, and this is like light green, and you can see the deposition. I will show you the deposition of copper. Look at that, FeSO4. I will show you the deposition of the copper, guys. Look at that. Look on the surface of the nail. Look at that. See the difference between the two nails. Look at that. Oh, look at that. The deposition of the copper start. Here, look at the color of the copper. It get deposited on the nail. You want to see the copper? Look at that. That's the copper. Look at that. This is the copper. And look at the solution. I want to stir that solution with the stirrer. Look at that. See the difference? See the difference between the two solutions. This is before the displacement. Here, look at that. So the deposition of the copper take place in that. Look at that. That's the copper get deposited. It's an easy experiment. So this is a displacement reaction. Look at that one. You know, in this experiment, what we have learned? We have learned the reactive metal easily displaces the less reactive metal. The reactivity is based on their ability. It's the property of their metal, guys. Some metals are very reactive in the periodic table. Can a magnesium and aluminium displaces copper? Yes. But the problem with the aluminium, when react with the oxygen, it forms aluminium oxide. Look at that. Look at that. I have put the nail just now, and the deposition of the copper start on the nail. The nail is the Fe, which was this color, means actually the steel, and I bought a brand new nail. There was no oxidation of the iron, yeah, and the copper get deposited at the nail, and you can easily see the bits of the copper in the solution. And the blue color solution, look at the blue color solution, very nice. This is the aquamarine blue color solution become the light pale in color solution. This is light pale color solution. So think over and answer that question. If you leave that FeSO4 solution in air for 1 day, what would be the color of pale green solution? Any guesses? Please do this one as a homework, and I will come back with this question, and I will answer that question in my next video. If you like this experiment, guys, please write down in my comment box. I will come back with such exciting experiment in my next video. Thanks for watching this video.